Okay, so I promise this one's going to be a lot shorter than the last one. Okay, sedimentary rocks. Look how beautiful they are. Oh, you ever go to the American Southwest? You'll see them. They're just so beautiful. Okay, let's talk about them. All right. So sedimentary rocks are ones that are formed out of pre-existing rock or previously living organisms. So they're formed out of volcanic igneous rocks, or they're formed out of corals. Man, that's some beautiful, healthy coral there. Okay, but that's basically how sedimentary rocks form. So most sedimentary rocks are, especially the ones that are formed out of previously existing rocks, are formed in the following steps. You start with a process called weathering. Then you have transportation, where the weathered material is carried to somewhere else. Then you have deposition, where it's let go to fall wherever it is. And then a process called lithification occurs, where it gets turned into a rock. Let's look at each of these in turn. So weathering just means the breaking up of previously existing rock material. And there's two ways in which this happens. You can have what's called mechanical weathering, which basically means like you're breaking the rock. And there's chemical weathering, which means that the exposure to water and oxygen and hydrogen ions, acids, they're causing different minerals to form. So minerals that were there originally get turned into other ones, and those minerals tend to get carried away. Okay, they're often when chemical weathering tends to turn things into a particle called clay, which is easily moved away. So let's just look at some different examples of mechanical weathering. So one way in which rocks get broken up is the actions of plants. Plant roots tend to expand over time. They tend to find their way down. They're following the moisture and cracks in the rock. And then as they expand, they tend to break them. I think these are beautiful pictures. I've got to see this. My wife and I hike all around the Seoul area, and we see this all the time. I always take pictures on my phone. I never think to put them in my presentation. But I've taken a million pictures of these to show you. These are not mine. A really important one is called ice wedging. So the idea is water gets into cracks in rocks, just like roots do. And then what happens is when it gets cold, the ice freezes. And if you've ever put a can of soda in a freezer and told yourself, I'm going to remember it later, and you forgot, that can will burst open because water has a tendency, water molecules have this right-hand bend to them. And what happens is when they freeze, they tend to go like this, and they form these six-sided crystals that have a lot of open space in them, so that they expand. And there's a lot of pressure when that happens. And so it can take this here and crack it open like this. Or it can, as it forms, it can take little pieces and push them out. So the ice is a really rapid, powerful way of weathering rock mechanically fairly quickly. Another way that mechanical weathering happens is gravity causes things to move down. And when that happens, they bang against each other. So like here we have rocks that broke apart because gravity made them fall down a hillside. You can see they broke into smaller pieces. I can see these used to be all one big rock up on a hillside, and now there's a whole bunch of little rocks down here. Okay, and if it wasn't a road, it'd just be nature, but it's still the same thing happens. So that's mechanical weathering from falling, but also when they tumble down rivers. When you take these boulders, and when there's a flood, they'll move, and as they move, they crash against another rock, and they break into smaller pieces, and then into smaller pieces, and into smaller pieces. So those are two main ways that gravity can cause mechanical weathering. Now, chemical weathering is basically, and it's hard to find a good picture of this, although I see it in nature all the time, okay, which is the action of water and oxygen and acids can cause minerals that are common, okay, so things like plagioclase and biotite and muscovite. Why do I have to say that? Okay, basically, these minerals are very easily converted into what are called clay minerals. So it's almost like the rock looks like it's literally, it looks like it's just dissolving into clay as these chemical reactions occur. And clay is easily moved compared to the rock material that they were formed from. Now, it's worth noting that chemical weathering affects basically every component of a rock with just a few exceptions. And one of the main exceptions is quartz, silica. Like I talked to the other one that makes volcanic lavas so viscous. So in the interstitial spaces, like I said in the previous one, that quartz is the last thing to crystallize out. It has the lowest melting point of all the components that make up, say, granites or basalts or whatever. Okay, so what happens is the other things, the other minerals form first, and then the quartz has to sort of fill in what are called the interstitial spaces. And then what happens is when these other ones get chemically weathered away, you just have these little pieces of quartz which over time break, and they form these little pieces here, which is just sand crystals. So the sand you see on the beach, or sometimes silt, which is offshore, these are just little tiny pieces of quartz. And the reason they're still around is because it's completely resistant to chemical weathering. Water, acid, Uh, Oxygen, none of it affects it. That's why we use it for lab work. That's why glass is basically just silicon dioxide, which is what quartz is. We use it because it's so resistant to chemicals. Now let's talk about transportation. So we start with weathering, be it mechanical or chemical, and then we have transportation. So basically, when the wind blows or the water flows, it's going to pick up things from one place and carry them to some other place. All right, that's just transportation. And in the process, it can also cause, you can see here, it can cause further mechanical weathering to occur, like when rocks tumble in a river or when things undergo what's called saltation, when they bounce along the ground. If you've ever been at a beach when the wind's blowing hard. Uh, but the bottom line is things start in one place and they end up in another place. Now, what's important about transportation, though, is it has this ability to sort things out by size. All right, and this will make sense in the next slide. So transportation is just the movement of rocks from where they were weathered to where they eventually end up being deposited. And in that process, we tend to sort these things out by the size of the particles. So deposition is basically when I deposit or drop the material to the bottom. All right, and basically what this means is the movement of the water or the air has slowed down so much I can't hold that one in suspended anymore. If the wind's not blowing strong enough to move a grain of sand, the grain of sand just sits there. The wind blows harder, the sand moves. The wind blows even harder, the gravel moves. When the wind slows down, first the gravel stops moving, then the sand stops moving, then the silt stops moving, and so on. So when that happens, deposition occurs. Now, here's what's important about deposition. As I said, it tends to sort things out by size. So let's just say the water's moving very fast here. It's moving fast enough, it can move sand. At first, up here, it could move sand and gravel. Then as it slows down, it's not moving fast enough to move the gravel anymore. So what happens? The gravel gets deposited. So you'll get a layer of just gravel, because if there was sand or silt or clay, the water's still moving fast enough to keep those things moving. But then it slows down even more. Now it's not moving fast enough to keep the sand going, so then you get a layer of sand that gets deposited. But the silt and the mud, they're still small enough they're being moved by it, but then it gets even slower, and then the silt falls out. And the mud's still being carried, and then the mud is the last thing that falls. So what happens is you tend to sort these things out, where I end up with, like, you get gravel here, sand here, silt here, and mud here. So the important thing about deposition is it's a sorter of sediments by size. So here's a pretty good graphic here. So here's gravel. So maybe 2 millimeters or more in size. Then we have sand, which is about 1 millimeter size. Silt is considerably smaller. And at this scale, we wouldn't even be able to see clay. But here we say if this is sand, then here's silt, here's clay. Now, it's worth noting that sand and silt are often both made of quartz. All right. The difference between a sand grain and a silt grain is just size. Okay, but clay tends to be a different mineral type. So clay tends to be a mechanically weathered material. What was a different, say, like feldspar in a granite, turns into clay particles, which are quite small. Oh, it's worth noting. Okay, so when if I see gravel deposit, I think, yeah, this was deposited in a fast-moving river or a very energetic beach environment. Okay, if I see sand, I think, okay, it's a normal beach environment, or maybe it's a desert. Okay, the wind blows, it can blow the sand around, but any silt or clay just gets blown away. All right, silt, I think, oh, it's a slow-moving river bottom, or maybe it's a lake, or maybe it's just offshore from where the waves were. The waves would keep the silt up in the water, but once you get beyond that, they'll settle to the bottom. And when I find clay, I think, like, I'm basically in a big deep lake, or I'm very far away from shore. So like I'm like, maybe like half a kilometer or more offshore, and then the clay is going to settle down to the bottom. Now, the last step is called lithification. So lithification, basically, lith means rock. So it's basically, how do these sediments turn into rocks? Well, basically what happens is this. They start off with water between the particles, right? Because they usually get deposited in a water environment. And then what happens is, as more stuff gets packed on top of them, they get squeezed down. So compaction occurs, which drives the water out from the inside of them for the interstitial area. And then over time, what happens is minerals will begin to form, like things that were ionic compounds, like calcium carbonate, for instance, or silicon oxides. They'll come out of solution and they'll glue it together in a process called cementation. Now, let's talk about ones that do not derive from weathering, and that would be limestone. Would be a classic example. So limestone is a sedimentary rock that has a different formation altogether. It's basically formed out of an accumulation of shells and coral. So it didn't get transported. Basically, what happened was you just have coral and shells, whatever, in place, and when they die, they just pile up on the bottom. And over time, if you've ever been to a reef, when you step on the bottom of a reef, it's hard. It's like rock. Well, it's just piled up coral and shells that over time kind of pack together and glue together, cement together, and that's limestone, we call it. Okay, and so it's still it forms a rock layer, a very important kind of rock layer, but it didn't involve mechanical weathering. It didn't involve, I mean, I guess you could say it broke apart, but it doesn't even have to. Sometimes just shells, okay? But it definitely involves compaction and lithification, but it doesn't involve transportation. Another important one is coal. So coal is a sedimentary rock. You find it between layers of rocks, okay? There's sand here, there's shale here, sand, mud, and then also there's coal. Like, coal is basically swamp material. So it's basically, instead of being reefs material, like instead of shells that are in it, it's made from living things. But instead of being made of shells and corals, it's made out of trees and other plant material that were in a swamp environment where there was low oxygen. They couldn't rot, and so they just built up over time. But again, compaction expels water, and then lithification process happens. So it's slightly different than what happens with limestone. And I believe, okay, the last thing here I want to say is this. Here's what's so cool about learning rocks. Like, a lot of people think they're boring, but they're not, because once you know them, they tell a story. Okay, so a key word here is depositional environment. What is the environment in which this rock was deposited? So if I see a sand, I know, hey, this used to be a beach. If I see coal, I mean, hey, this used to be a swamp. Right? So it's kind of powerful, the information it gives. So let's just go through this real quickly. A conglomerate is a name for a rock type, sedimentary rock, that's composed out of gravels. And so if I see a conglomerate, that means, oh, you know what? This was a fast-moving river system, or this was deposited in a very high-energy beach, or this was deposited as a result of a tsunami. If I see a sandstone, well, sand, basically, the environment where it gets deposited tends to be either fairly, somewhat fast-moving rivers, or more often than not, beaches or deserts. If I find a siltstone, which is finer grained, considerably finer grained than sand, but not made out of clay, I know, well, this is a nearshore environment. This is like just beyond the breakers is where this got deposited. So when I say, oh, this area used to be just outside of the breakers on a beach area. If I find shale, shale is a word for this kind of like dark kind of layered rock that's made out of clay particles. And I know, like, okay, if it's clay particles, I know I'm fair ways offshore in a very quiet environment. It's the only place that we get put down. Now, if I see limestone, I know it used to be a coral reef or a reef of oysters or something like that. So I know it was a reef of some sort. And if I see coal, I know it used to be a swamp. So basically, the cool thing about sedimentary rocks is they tell a story about the past. You can look at them and you can reconstruct the past environments, the depositional environments, just simply based on, in most cases, just the size of the particles present. Thanks for watching.